So today we're going to talk about the lists, and then mainly we're going to focus on linked lists, and we're also going to compare the linked list with our, with the array list, and then we're also going to next week we're going to cover all of them, and we're going to have all of stack and queue as well. So these are going to be the materials that we're going to cover. So for all of these data structures, collection data structure that we're going to learn, we're also going to start writing code for them. We'll first introduce them, we'll explain like what is the idea behind them, what is the structure behind them, and then we're going to start coding them together. And then when we're done, like whenever we're done with the linked list completely, then you're going to submit, like what we did with the game, you're going to submit your entire linked list code. And same thing for the array list and stack and queue. A sample of those available in the slide folder from like 5-6 semester ago. We're still kind of improving it as every semester a little bit. So that the version that you see on the slide folder for the list, again, it's not exactly going to be like what we're going to implement in the class, but you're getting some idea, and then also you basically can, if you want to at the same time writing code with us, you at least have some part of the skeleton. So as we know, the list basically, or collection, is whenever we want to store some data, we need to have some sort of a collection. So the default collection that we have in Java is the fixed size array that we already learned, right? So that means that we're going to have a block of the memory. So this is my memory. So you're going to have a block of a memory, and you're going to say exactly what is going to be the data that you're going to store. So you're going to have your data type also in that basically when you are starting creating your array, you're going to give us all the information. So that block of the memory, exactly with the size that you want, is going to be allocated to the list that you're trying to use. So they're going to go back to back. Okay, here's my pen. So again, bear with me a little bit. I'm trying to learn this tool as well. Not giving me my pen. Okay. So this, can I move this one? Oh, okay, perfect. And so what? Okay, perfect. So now basically if I create an array list of size 5, for example, the memory is going to be allocated for it, and then I'm going to have the access to the address of the very first one. So that's basically what we learned about the list. So if this is my list, the address of the very first one is going to be stored in my variable for the list, right? So, and then I have access to the very first one. And the good thing about the list, the array list data structure, is that they're back-to-back in the memory. So you can have random access to any of your data immediately. Like, so basically, it's going to be order of 1 for us to have access to any of the element in this list, right? So you can say list, and then you're going to point to that particular index. And the reason is, since we have the address of the first one, when I said list at position 3, it's immediately going to calculate the address for that, and it's going to give it back to us. So it's going to be really order of 1 as far as getting access to the element in the list. Another thing about the list that's actually going to be a little bit problematic is that if I originally create an array of size 5, and then I now have more elements, so I start adding elements to it, right? So 5, 6, 7. My 6s look like 0. That's okay. It's not a big deal. And so when we start adding the element, at some point, it's like, I want more elements now. And so I cannot use this array anymore because it doesn't have enough space. So as you remember, we said the only way that we can now fix this is that creating another completely new list with a size that is larger, whatever new size that we're looking for, and then we can actually copy elements from the first list into the second list. So the second list is going to be completely in a different block of the memory, but they're also going to be all the elements back to back, like the, you know, any, that's also a fixed size data structure. But what we did, we manually created a larger size, and now we have to copy the element from the old array into the new array, so we can have a larger size array. So for more normal people at their programmer, basically, it's not a big deal. But if you want your users to do that, like, you know, somebody is using your program, and then you want to say, okay, you need more space, okay, go ahead and copy your memory and create a new one. So that's not probably a very efficient way. So that's why Java, for its users, we are users of Java, they provided this dynamic list that's called ArrayList, right? So the ArrayList is going to be a dynamic list. In the background of it, so if you're going to basically look at the look at it as like a class diagram again, in the background of it, we still do have our fixed size data structure as the, I can hear myself, as I guess I have to mute everybody, so you can also mute yourself. Sorry, so in the background of it, it does have an array, fixed size array data structure. So when you're creating an array list, right, so that's how we're trying to write the array list here. When we're creating an array list, I guess I just use this feature. So when you're creating an array list, for example, in Java, you have to basically call a constructor. Now it's an object, so it has 3 different constructors that you can call in order to create the array. So you can say our array list, for example, array1, and then you have to call new, and now you have to go ahead and say array list again. That's the constructor, and then here you have to provide a list of the parameters. So you know the constructors, you have the list of the parameter to provide. You can also call the default constructor. Like what I'm going to do here, it's going to call the default constructor of the array. So if you remember, we talked also about the string objects. Remember what was in the background of the string objects in the you know, basically when you store or creating a string object, what we have that it helps us to store everything actually in the memory. Remember that? Character array, right? So that was also fixed size character array, right? And but it was specifically the type of it was character, and it's going to basically, whenever you create any string, is going to store them in that. So basically, if you create a new string calling the string constructor, the default constructor, remember, it's going to just create for us a character array. What is the size of that character array is going to be created? Is there any default size for it? Remember that? So what is the default size for the character array in the string object? And keep that in mind, the string is an immutable object. So what makes sense to be the size? Because every time you change it, it's going to completely destroy and create a new one. So what is going to be the good size for a character array that nothing is in it? 0, right? So remember, the character array, the default size character array in the string objects is 0. Doesn't have any size, right? Because, and that's because the string is an immutable object. So if I create a string that is nothing in it, and then I'm going to start adding new to it, that immediately I create a completely new string now. And so that means the old one is no longer going to be used. So to store, saves memory, the default constructor of this string is going to create a character array of size 0, because you're never going to use it anyway. So now in the array list also, we do have the same thing, like what we talk about in the string buffer or string builder, right? In the array list, we're also using the array fixed size array data structure in the background. And so whenever you're going to create your array list, you now have to also provide what is going to be the type. So that's what we call generic. So this is going to basically kind of force you, probably here saw this kind of shape that whenever you're creating some of the library objects, is asking you to provide the type of the data structure that you're going to store in it. So you know, for example, what we're going to do in the class at the beginning, we're going to make all of them to be a string. So we're going to create the character array basically in the background of the string type, or basically a fixed size array of the string type or integer type. Whatever you're going to provide here, that is going to be the character, the type of the fixed size array that is available in the background of the array list. So based on whatever information you give it, it's going to create an array with a particular default size. So what is the default size here in the array list? What do you think it is? It's not immutable. So what we have to come up with in some sort of the default size now. So what is going to be the default size for this array that we have here? Any idea? No. It's actually 11, I believe, 10 or 11. So string buffer is, I guess, 11. One of them is 10. So I don't remember. We can look at the basically the specification of the array list, but that's going to be the either 11 or 10. So that's the default. So when you're calling the array list default constructor, is going to create and providing a particular type is going to create an array of in the background of that type with the size 11. So that means you can now start adding 11 data into it with that type, and at some point it's going to get full now again, right? So same thing as what we just did, this fixed size, because in the background it's a fixed size array anyway, right? So now what is going to happen, instead of asking the users, which is us basically, to now you don't have a space, go ahead and copy and create a new larger size array and copy everything into that, it's basically going to do it automatically in the background. So basically there is a method in the background that's working and always constantly comparing the size and the elements that you have inside your array, which we call it basically the capacity and the size. And the concepts of capacity has become very important in this case. So the default size basically is our capacity. So it's going to compare the capacity and the size, and size is the number of elements that you actually store in that array. So whenever the capacity and size is getting close to each other, what does that mean? If I have size 11, if I have a capacity of 11 and I have 10 elements in it, what does that mean? I mean, I'm getting very close to become completely full. I mean, I don't have any more space anymore, right? So that's exactly what's happening in the background. It keeps checking the ratio between the size and basically the capacity. So whenever it sees the ratio getting very close to the 100%, it'll start creating a double size array. So whatever is the size of the array originally, like if it's 11, it's going to double size of the array to 22, and it start automatically copy all the elements from the original array into the new array. And all things happening in the background without even we realizing it, right, as the users of the array list. So that basically the same concepts of copying to the new array automatically is going to happen in the background. So there's a method resize, and that's the one, or actually grow, that's the one that's going to do that. That's a private method, so we cannot go ahead and change that, or you can look at it as far as implementation if you have access to the specification, but we're not going to be able to change it. It's going to automatically call whenever it's needed to increase the size for us in the background. But also you can imagine, maybe I originally create an array of a really large size. So we have actually three different constructors. So one of them is a default that we just see here. So we're not providing anything, and it's going to use a default capacity. The second one is actually asking for a capacity. So you're going to be able to enter an integer value, which is basically going to be the capacity of your array list. So if I provide a capacity, like for example, like if I provide a capacity 100, so I create an array list. I can't. It doesn't let me to edit the original one, so I need to create a new one. I got used to lose to this blackboard or the whiteboard. So when you create the array list, so for example, array 2, and this time you're going to call the new constructor, the other constructor, and now this time you have to provide the size. So this is a capacity. So you can tell that I want to create an array list of size 100. So now it's not going to use, it's going to basically override the value of capacity from 11 to 100. So it's no longer going to use the 11. So from the beginning, it's going to create an array of size 100. And that means it's going to block that part of the memory completely for you. because again, keep that in mind, a block of memory is going to be allocated to basically to your array fixed size data structure. So in case that you're not going to actually use the entire list, like imagine originally you thought you're going to have 100 data to store, but now you only have 40, and so basically now you have an extra arrays capacity that you're not going to use it, and so basically you're wasting your memory. Java is providing, it's not going to automatically shrink, but it's going to provide a method. It's called trim to size, right? So the trim to size method can be called, which is basically on one of the methods in there. It's a public method that you can call, and it's going to, you basically automatically is going to grow, but then it's time to shrink it. You have to call yourself, you have to call the trim to size. So they're not going to automatically do that. So we're going to implement our own list, or basically I'll call it MyArrayList ourselves in the class, and we're trying to implement the resize, and also on the top of that we're going to make it generic. So we're going to talk about these concepts of generic, and as we're talking about these data structures. So now that we kind of see how ArrayList works, right? So we're kind of reviewing that. So we know in the background it's nothing but the fixed size data structure. So today, our more focus, we're going to be on, our main focus is going to be on the linked list.